Hi, my name is Siti Fatima and this is my group member Anwar Shura binti Muhammad Nuruzaki and Nordini Shahira binti Muhammad Zakri, and we will present about 3-bit digital analog converter DAC with weighted resistance. The reason why we choose the weighted resistance instead of the R2R non-inverting ladder DAC is because it is simple in construction and it provides fast conversion. Even though the R2R non-inverting ladder DAC have more advantages than the weighted resistance. This is our circuit. Here the MSB is stand for most significant bit and the LSB is stand for the least significant bit. Here are the binary weighted resistance switch, and this is the resistor, and here the ground, and here is the summing amplifier, and the V out here is for analog output voltage. Another member will explain about the operational principle of 3-bit digital analog converter with weighted resistance. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nordini Shahira binti Muhammad Zakri with matrix card number of AE180035. We'll be presenting to you about operational principle of weighted resistance DAC with 3-bit binary. So a DAC with weighted resistance produces an analog output which almost equal to the digital input. And the 3 bits of binary can only have either 1 or 0 as its value. And the 3-bit binary is represented by D1, D2, and D3, where D1 denotes the most significant bit and D3 denotes the least significant bit. And then the weighted resistance then denotes by 2R, 4R, and 8R, where 2 to the power 1 is 2R, 2 to the power 2 is 4R, and 2 to the power 3 is 8R. So when the digital switch is connected to the ground where the input bits are equal to 0, that means the switch will turn off and there is no current flow to the weight resistor. But if the input bits are connected to the negative reference voltage where the input bits are equal to 1, that means the switch will turn on, and that means the current will flow to the weight resistor. When all such current from different weight resistors get added, it will produce a potential voltage to as its output. Thank you.
Assalamualaikum warahmatullahi wabarakatuh and good day. I am Anur Ashura binti Muhammad Nuruzaki and my matrix number is AE180085. Today I will be presenting to you about the equation of 3-bit DAC with weighted resistor. First, based on the circuit diagram for 3 bits DAC with weighted resistor, the relationship between the voltage output and the binary input is as follows. Note, the total output current I0 is equal to I1 plus I2 plus I3. So, I1 is equal to VR over to the power of 1 times D1 plus I2 is equal to VR over to the power of 2 times D2 plus I3 is equal to VR over to the power of 3 times D3. Then we simplify the equation. We get I0 is equal to VR over R times in bracket D1 over to the power of 1 plus D2 to the power of 2 plus D3 to the power of 3. So this is the first equation. Next, to find the output voltage V0, we use the second equation, which is V0 equal to negative I0 times RF. Then, by substituting the equation 1 into equation 2, we get V0 is equal to negative VR times RF over R times, in bracket, D1 over to the power of 1 plus D2 to the power of 2 plus D3 to the power of 3. Okay, then we like RF equal to R, so we substitute R into RF. So we get the equation V0 is equal to negative VR times R over R times, in bracket, D1 to the power of 1 plus D2 to the power of 2 plus D3 to the power of 3. So the final equation of voltage output V0 is V0 is equal to negative VR times, in bracket, D1 over to the power of 1, D2 to the power of 2 plus D3 to the power of 3. Okay, from this equation, note that D1, D2, and D3 represent the status of the switch, either open switch or closed switch. Open switch means off. So when switch is off, we substitute 0 into the equation. And when switch is on, we substitute 1 into the equation. Secondly, for a 3-bit DAC, 3 switches will produce 8 different combinations of output, hence produce 8 different output voltage. So it's depending on how many bits we use in the circuit. So that's all from me. Thank you.